What's up, everybody? Welcome back. Today we are working on checkpointing slash weight saving and loading in our neural network training framework. So we are in the process, this long fucking rabbit hole of trying to scan a barcode on my phone in a web page to keep inventory of the stuff in my fridge so that I can automatically generate grocery lists when I start to run out of the stuff, right? I know how much milk there was. I know how much I put in things that I made. Now I know that I'm out of milk, and I can put a little reminder, go buy milk. And also I can do things like filter recipes. I don't really use recipes. I can filter for things that I've made before that use ingredients that are in the fridge, which should make like thinking about food, what am I going to eat today, a lot easier. That's kind of like the overall goal here. We started by running a barcode scanner kind of by hand, and we found a lot of like degenerate cases that we just didn't want to deal with, right? So if we like look at this, let's just like look at some of these examples. Egg carton, ew, look at this stuff. If you were to just take like a one-dimensional scan line across this, that does not work, right? Because like there's so much of the bars actually missing. You need some sort of like two-dimensional information, and you need to like average out over 2 dimensions, figure out where like the scale of the bars, all of that stuff. But then that gets, it gets kind of tricky because like sometimes the edge of the bars are not really like obvious, sometimes with shadows, the darker, like you can't even just like even threshold on dark and light, you need to like do some sort of like local contrast analyzing. There's cases like this where the bars are not even like black. They're the aluminum from an aluminum can, which creates mirrors, which creates all sorts of like weird degenerate cases like this. Sometimes the bags are crinkly, which makes like identifying like the segment that you're trying to look at kind of difficult. All of this is like solvable. Obviously, like you don't need neural networks to solve this problem, but it sure seems like more straightforward to me to let a computer figure out how to do all of this stuff versus doing it by hand. Right, and so we built a neural network training framework because we don't like using dependencies around here. And we're at the point now where, we train a little bit. We've got like basically like fake barcode data that we've started with. We might we might use like real barcode data later, but using fake barcode data lets us kind of like super control how this thing looks while we are working on like the neural network training framework side of things. And we have something where we can kind of take a barcode that we generated, slap it on top of some random image just so that there's like something that's not solid in the background, and we can predict some like boxes that are like okay, right? This is after like maybe like a minute of training. This is kind of what our network does right now. If we look at maybe an example, hold on, Viz, I think we had something here where we had like example graphs out star log CSV. It's probably something in here. We have some proof here that like maybe after 30 minutes or so, 20 minutes, it starts to like converge on something like kind of sane, right? So like you can see it starts to like stabilize, maybe at around like minute 10, 60 seconds in, right? Did our color matching change? It looks much brighter than before. I changed. I don't know what you mean by color matching. Maybe. So yeah, maybe like 10 minutes in, right? Before we get something like reasonable. So I don't want to have to train for 10 minutes every time I launch this thing. So I want to like write down what we decided were good parameters that I can look at the result of this 10 minutes of training later, right? There's other things that we want to do here. So sometimes we've noticed that like training will crash after like crash is strong. It will like hit some degenerate case after like 2 hours of training or something, right? When I'm training like certain types of networks, and trying to inspect how that happened is very difficult. So being able to like resume training from like around like the 1 hour and 55-minute mark would be really nice. And so kind of like both of those things mean we should write down what we're doing as we're doing it, and then later load that shit back. So that's the goal for today, is to find some way to like generically write stuff down and pull it back up. Kind of like the way this works right now is we've kind of got like the whole network definition in like a JSON blob. This is a Python file, but the Python file generates a JSON blob because that way we can like do math in it and stuff. But like what we do in here is we have like types of things that we can do as part of our neural network. We have like convolutions, we have like fully connected layers, we have like activations and all this stuff, right? And so this comes in here as like basically a stack of like stuff that we want to do as we train. And so what we have to figure out is how do we take this and turn this into something that has like parameters associated with it, right? That's probably something like each layer ends up with like an ID. And if it's a thing that has parameters, it like will look up somewhere in some like checkpoint somewhere. Do I have something associated with that ID? And do I load it? Anyways, we're getting into weight design, like data format design, which is the first thing that we have to do today. But after we do that, we have to actually implement. So that's kind of the plan. And let's start thinking. So we have this. This is where the weights are kind of coming from. We have to make sure that if we switch configs around, maybe we want to be able to like add a layer, but start training from like a point where all of the layers that previously existed are like initialized with their good weights, and then we only have to find like a set of new weights for this one extra layer. Something like that is something that we might want to do. So I presume that eventually we are going to want some sort of config where we write down weights. Let's look at an example of a layer, and maybe looking at that will give us some inspiration. Right? So we have something like a fully connected layer who has weights and biases in him. He also has a name. So he needs to save, this layer needs to save two chunks of GPU memory somewhere. Okay. The convolutional layer, he needs to store one chunk of GPU memory. What about Guga format for export? I don't really want to think about interoperating with other people right now. I think eventually maybe, but for now, I think we'll just do whatever makes sense for us. I think taking inspiration from the GLTF file format makes sense to me. So there's this like model format where for like interop between games, but between like your Blender and your game engine, right? This is like a thing people do, where you'll make a thing in here. Maybe you'll like move this vertex around, and you'll be like, this is the thing I want in my game, right? And you'll like take this and you say export GLTF. Let's be careful here. Separate is easier to inspect for now. And what this guy does is he untitled GLTF maybe? Yeah. He exports this like JSON file who references kind of like external binaries, right? So he says in here, hey, I've got like a bin file here called untitled.bin. And, you know, if I want to look at my mesh data, like where are the vertices on this cube? He says, yo, I've got indices 3. And I think that comes from buffer views 3, which says like, hey, I reference buffer 0, I'm 192 bytes long, and I come from like offset 576, and buffer 0 is this like untitled bin. Alright, so I think that idea is not crazy. Like this idea of having like a spec that's like easily parsable in JSON that references like binary data that sits adjacent to it seems kind of nice to me. Right? So I think that we can do something similar, right? Where we take our config, we export like the layers section of it in a way that it has like IDs associated with it. And each ID will say, hey, I am like a 4x5x6 tensor. And that tensor sits on disk in our like weights file that sits next to us at this offset with this length. Right? I think that all makes sense and is fairly straightforward to implement. So let's try that. So like what would that look like? Okay, wait, hold on. Let's generate a config. Default config. So this is the input to training. Let's just put this in temp.json or something. Wrong environment. Hold on. So this is the definition for everything that we need. And let's say that in network, the layers section of this thing should be in charge of saying where the weights come from. Maybe not. Maybe in here, when we load this thing, we're trying to resume training. Maybe here we say checkpoint comes from checkpoint dir, right? So maybe like there's an adjacent, like some file somewhere, some folder that has the spec and the weights in it. That seems reasonable. Okay, which means that we get to define this however we want. So if this is how this works, it means that the layer definition is not part of the checkpoint, right? The layer definition is part of this config. We don't need to duplicate that. There's no reason to duplicate it. So then in our checkpoint directory, the simplest thing to do would be like, okay, make dir checkpoint dir. It would be like checkpoint dir, like spec JSON or something, right? And in here, the easiest thing to do for now, without thinking about like forward compatibility and anything, like we'll say that this checkpoint is only valid for this specific set of layers. And we aren't going to do any validation of that. We're just going to assume that you passed the right checkpoint. We'll start there. He would probably say checkpoints. And he would just have some checkpoint definition for every single layer. Right? So here we would probably encode like assert that checkpoints len is equal to layers len, and then in here we probably have like dimensions of the checkpoint of the thing, right? So like this is like a 3x3 by 5x6 thing or something, right? And his like data comes from some like data definition that's like we probably have like weights file here, maybe this is implicit, but I think putting it in here is like kind of nice. And so this is just like offset. I think that maybe it's just as simple as doing data offset, right? Because the size of this is implicit from the dimensions. And so this kind of just works. This is like V0 of this thing, and I think that that's kind of fine. Now, I do think it would be nicer to have... Oh, hold on. We have a problem. It's the fully connected layer exports two... He exports two sets of weights. One for biases and one for weights, like weights and biases. Sorry, two tensors he exports. So I guess that this needs to... Each one of these needs to be either a list or a key value thing, right? So if we're in like the fully connected layer, we would have like maybe something like this. So this is a set of fully connected weights, and the fully connected weights have like their own data type, which is they are an array of things, right? And so then he's like, yo, we have our weights, who would be like maybe something like this. I guess the way that Zig would auto-serialize this stuff would be kind of like this. Yeah, it would be kind of something like this. Yeah. These dimensions are wrong, but whatever. And then we would have like another option of conv, and the convolution, he just goes straight into like one of these guys. Yeah, I mean, that seems like it kind of works. That seems like it kind of works. And so then our assertions are also that like the types match. Assert that like weight type matches. In code? That seems kind of reasonable. That seems like, yeah, I think that seems like pretty straightforward. Maybe. Yeah. If we want to do like weight IDs and or like checkpoint IDs and stuff later, or sorry, layer IDs and stuff later, we can do that. But I think for a V0, this is fine. This will work. So let's call this done and start writing some code. Okay, so I guess we need like checkpoint zig or something. And this thing is just gonna be like whatever we wrote here, right? So we have, can we call this like buffers or something is maybe a better name for this? Layers? We'll find a better name for it later. Okay, so we have weights, which is a string. And we have layers, which is layer checkpoints maybe is a better name for this. And here's a list of like layer checkpoint. Okay, pipe. And this is a union enum, easy. And he's got probably like a lot of these will be null or like none, right? Like a rel-u layer doesn't have any weights associated with it. He has no learned parameters, but he's like a layer in the list. So we have to be able to like stub that out in some way. Then we have like fully connected, which we said is going to be, you know, weights weights of something. I guess we have like buffer. So he's got like the offset in usize, file, like data offs, file offs, elem offs. I guess we should be clear here. If we want offset in bytes or in elements. I think elements is nicer for now. We just assume everything is like raw floats in disk. Gotta go, see you later. And then here we have like dims, which is a bunch of U32s. Sure. Okay, so we have like weights, buffer, biases, buffer here. And then we have like conv, which just goes straight to a buffer. Cool. This seems reasonable so far. The question we might want to ask ourselves here is, do we think that the layer should be in charge of the schema of his checkpoint? Probably, right? Like the idea here that we have like one file and he owns all of this stuff seems like kind of wrong. A little bit. It's almost like, I wonder if we can do something like this where each checkpoint is like a JSON blob in and of itself. I guess this becomes like import std, and each of these become like a std JSON value or something. And then we can parse this JSON value the way we want. And then that makes it so that this doesn't have to exist. Having this type around is nice, that everybody can agree on the same buffer format. But sure, that seems reasonable. And I don't know how, usually I would try to avoid JSON in the interface here. Really, like what would be better is if we had, like it might be better if this is, if we had something that's like checkpoint layer checkpoint is, you know, maybe something like this, where you can export in certain ways. So you can export with like by like key value. You know, like string hash map, you know, like something like this, or like direct. Maybe we just always do a key value like this. You know what I mean? Like, and then we can like serialize and deserialize this the way we want. I guess this thing could still be a std JSON value, but the interface of how we create these things can be a little different. Sure, we'll kind of start here, and we'll see how it plays out. Because I would love to keep the option of like having the serialization stuff live here and not as part of the weights stuff. But I'm sure that this will become kind of more apparent how this is supposed to work as we implement. Okay, so let's go to like a layer. Let's go to our like layer interface. And so obviously here, he's gonna have like a like save weights. Export weights, which sounds a lot like get weights. There's a good chance that whatever this guy's doing is going to get folded into this later, but we'll kind of keep it as like a separate thing for now. So you have to ask every layer type if it accepts a JSON blob for deserialization. Yeah, I'm not sure. I think that I would more want it to be like, here is a hash map of weights to their data, maybe. Yeah, and then that gets like fed into the checkpoint system somehow. Right, so maybe this guy exports. Like maybe I have some weights, maybe I don't. And here is a string hash map of what? Like key, so the key of the thing that my weights are for going to their data. Right? So he's like literally just this. And so this thing probably needs some allocator to put that stuff on. That seems reasonable. That seems super reasonable. And then when we load, we also get this hash map back, and we just have to figure out who's in charge of like stitching that together. Yeah, that seems reasonable. Yeah, we'll see. Actually, I don't like hash map here. I think I'd rather have this be like exported weights. Exported like I guess like weight param maybe or something. Don't really know how I want to call this yet. But here we'll have like key like this and val like data. I guess we need like dims here. And I guess this is kind of like a CPU tensor. Which feels also kind of wrong. Like from like an interface perspective, this guy works on like math tensors. So he should just give us one of those. That kind of makes more sense. So here we're like, you are backed by some executor. And you own your data as like his tensor type. So we should just do this. Key name and then tensor is literally just like executor tensor. Yeah, that seems great. So this guy, when we export the weights, we return just a list of these. Yeah. That seems good. And then we can work with like the serialization stuff externally. Wonderful. Wonderful. Okay. And then he probably doesn't even need an allocator here. Because the names are probably hard coded. Yeah. Yeah, this is great. This is great. Okay, so here conv export weights. I guess we make it so that this function is like optional to implement. Because like some things will not. And so here convolution, he definitely has export weights. And his like export weights is literally just like return. Oh, he needs an allocator to make the list. Yeah, he does. Because I guess technically from externally, we don't know how many of these things we're going to be out returning. So he needs to like output a heap allocated thing, which is fine. Alloc stood mem allocator. And what is it? It was a... This thing also doesn't have to be optional anymore, so you can just return an empty list. Great. Okay. So he returns just a list of wait param executor. Okay. Easy. So he's just like alloc create or alloc, he's literally just like one wait param executor. Yeah. And he's like ret 0 is just like kernel key tensor is kernel. Wait, this is great. That's easy peasy. Okay. Export weights is null for relu because there are no weights. Who else? Fully connected, he has to export weights, so we'll figure out how to do that. He's using some allocator. And what does he return? It's like a list of wait param executor. Easy. So he returns like he allocates 2 of them. And he's like, ret 0 is key is weights. What is it? Value? Tensor? I don't remember. Tensor, yep. This is a self, comes from converting the context pointer, easy, and ret 1, oopsies, biases, self biases. Easy. Easy peasy. Max pool, export weights null. He's not exporting shit. Export weights null for reshape. Doesn't have to export shit. Okay. So now all we have to do is every once in a while export the weights. So I guess in our like, where's this gonna live right now? In our like train loop. This feels like something that could live in trainer. Right, so every time we do a step here, maybe we initialize this guy with like checkpoint freak. We do like our iteration tracking in the main loop, so we might as well do it there for now. For now, rip disk space? No. We'll only do it every once in a while. We'll be fine. In reality, like, I'm not really sure that all of this should live in the main loop, and maybe it should be part of like some sort of like generic neural network stuff. But we can just say here, like, if iter %config checkpoint freak is equal to 0, we write that shit down. So that means config needs to have checkpoint freak here. Easy. Just a button in the UI. Well, it has to happen automatically as well, is the thing for like when I'm doing like long experiments overnight. So here we say like for each of our layers, we like export the weights. So here we probably like take a checkpoint of the scratch allocator, which I guess it kind of will disappear for free. So we just literally just use like CL allocate because this gets garbage collected very soon anyways. Calling it garbage collected is like kind of wrong, but like whatever. And like in reality, like the amount of allocations we're doing is like very slim. Okay. I guess we should. So now we need to like copy these weights to CPU. So this is like tracing executor to CPU using this again. Okay, and we're using weights tensor here. And what is it? It's like, yeah, we should definitely checkpoint here. Reset checkpoint. Okay. So we just write this shit out somewhere. So we have some sort of like weight writer. What if you go potty and answer for you? Like, yeah, exactly. So this is like CPU data. And surely we have some sort of like checkpointer. I don't really know what this looks like yet. Probably like init with outdir and probably some like name, right? We probably have like checkpoint name is equal to should format alloc print or something. Not really sure yet. This guy lives on this guy, which will get garbage collected, so it's fine. And this is going to be like checkpoint with the iteration number, I think is fair. Okay. Which kind of indicates to me that like if we allow like resume training, then the checkpoint should probably have the iteration in it as well. But we'll figure that part out later. We'll put like a fix me load initial iter from checkpoint. I'm pretty sure that has to be done. Pretty sure. But then we can just like write the name here, right? Bing, bang, boom. And he will like open the files that he's got to open, figure out like the JSON thing, and every iteration of this thing we go right, and we just pass in the. I mean, it might just be like we pass this in directly, to be honest. And then he's in charge of loading from CPU and stuff. Yeah, it could be, right? So this guy takes in like tracing executor here as well. I guess this kind of is like, this kind of is just turning into a function where we just call like write checkpoint at checkpoint name or something with layers. That's kind of what this is turning into, right? That's kind of what this is turning into. I guess. Maybe something like that? Okay. And then in there, we have checkpoint zig, pub function write, with name. We have like executor. We have layers, so nn is equal to import nn zig. Right, so kind of like this. Outster, probably somewhere. Yeah, okay. So here is like outdir make dir name. So this is kind of like checkpoint is this. A checkpoint is a directory. Okay. Figure this out. And so then this stuff kind of ends up down here. So this is tracing executor. Outdir checkpoint name layers. Okay, cool. So all of this stuff now comes down here. Looks like we need an allocator. Okay. Cool. Executor here. And now we just have to start doing the shit. So presumably we kind of have some sort of like intermediate value. Yeah, so each of these guys we've determined now is just this is a list of nn weight param. No, this is gonna be its own thing. This is just a list of buffers. A list of buffers? Yes. So each layer exports multiple buffers. Each buffer has a key now. Is kind of where this is like started looking like it's going. And now we have like our layer checkpoints is like layers len. Yeah, we have like here we have like many of these. Just kidding. This is a list of buffers. And so we go for layers, layer checkpoints, layer out, like this. We say layer out is equal to, we allocate a bunch of buffers here that match weights len here. Okay. Yep. And then for weights layer out, we have like param out. And for each of these, we say we do this. Param out is equal to, and this is like a buffer, right? So it's like key is waits key. Dims is waits dims or param, sorry. This is param tensor dims, I think. I think that's how this works off. And then the lm offset is like our waits output, like how far we've written to this thing, right? Which we have to find eventually. And then we presumably write the data out here. So we go like waits, output, writer, write like stdmem, slice as bytes. Something like this, right? That seems like reasonable to some extent. To some extent. So this is a little sketchy because we tried to checkpoint the allocator here, but we are trying to save his key here. And this key comes from this, so we can't do this. But we can just do it, we can just checkpoint after we export. So here we say checkpoint after export, so name stays valid, but before to CPU, which copies a bunch of stuff to CPU that we only need temporarily. There we go. That makes life easy. Cool. So now we just need our output writer. So we have like data out, I guess. I do like the doing data there better, or like bin data writer maybe. So here we have like bin data is going to be checkpoint create file of waits bin or like data bin maybe, and oh, this makedir doesn't actually open it. It's like this. Checkpoint is out dir open dir name. It's like this, I think. Okay. So then we need like probably we have like bin data buff writer is std.io buffered writer of bin data writer. And then we need to count, right? So, because we need to keep track of where we are. So we have like counting writer. Is gonna be wrapping the buffered writer, I think. Okay, so it's like something like this. How does Zig narrow down the executor parameters in any type to something that can actually look up the executor methods on? It's like C++ templates, right? So you pass in a thing, and it like compiles a different version of this function for each parameter, each type of parameter that you pass in. So the compiler, once it's called, it's just like, oh, there's like a concrete type here. It's not like an any type. It's like whatever you had. Okay, so this is counting. So I guess we have like data writer is what we should call this. So this guy fulfills the interface, and then we have like counting writer. Is that what it's called? Counting writer, yeah. Counting writer pause, which is maybe bytes written here. Okay. And then here we have like data writer write all, maybe? Yeah, okay. That like might work. I'm like on like a 30% that that's correct. Maybe 50. Type of executor. I think we're assuming this thing comes in as like a pointer, I think. Okay, so this guy, he needs to pass in executor, Alec. He's missing seal Alec here. Okay. Var here maybe? Layer checkpoints here needs to be tried when we allocate. If this thing fails to flush, then like I guess we should sorry. Does this thing ever return early? Probably not, right? So we can just do this. Without any problems. Okay, this guy's mad because what? Oh, if export wait, if self v table export waits, we call the function. Else, return empty. Which means that in our checkpoint writer, we need to check for that case. Right? Like here, this should be a list of optional list of buffers, right? And if this thing does not export anything, if waits len is equal to 0, we say that like layer out is equal to null, and then continue. Otherwise, we make it what we want. Cool, which means layer out needs to make a list of optional buffers. Cool. What's he mad about here? Right. So here we do reference the optional. Okay, and then here we already have this thing as a pointer, so we don't need to do that. Tensor here doesn't exist because this is param dot, not waits dot. True. Oh, and at the end of all of this, we need to write out the spec, right? So we need spec is spec JSON or whatever the fuck we want to call this. And in here, we write out this thing that we made. So here we say like spec is a checkpoint. Spec file, defer spec file close, and we can just like spec file write all of stood JSON stringify. You know, self in some way. So we have this stuff. Layer checkpoints is whatever the fuck we made here. Layer checkpoints. And waits is just hard-coded as data.bin. This feels kind of nice. Outstream. So it's actually this way. He goes to spec file writer. All right. We probably want like indentation here. White space is indent 2. All right. Non-zero chance that this works. So we just need our default config to have like a checkpoint freak here of, let's say, 100 for now, just that like something trains. And let's see what happens. Let's see what happens. And we don't need to be in optimize mode. Fuck it. I think we have a folder that does not have many backgrounds in it, so let's use that one. And he crashed. All right, seg fault. So we are fucking up. We probably are doing like some like stupid allocator reset shit that we shouldn't be doing. We probably fucked this up somewhere. Yeah, I mean, this is fucking brain dead, right? That seems way more reasonable. Okay. How we looking? Okay. Okay. Those are maybe, these are some fucking checkpoints. So here we have what looks to be a bunch of floats. Okay. So here is like, yeah. Okay, so here, this is looking promising, right? We see, you know, offset here. Oh, this is in the wrong unit. This is probably in bytes. So, okay, kcalc, we have 576 times 128 times 4 plus 2704, 279616. Yeah. So here we wrote these weights in here. I guess we can just say, we can just change the format from elem offset to, this should just be byte offset, and then that fixes a lot. Okay, cool. And so now we have something that might be right. Might not be, but might be. So how do we prove that it's correct? I guess we check if it looks like kind of valid floating point data, right? So what we can do is we can run this for a little bit, hit pause, look at the weights for these things, and see if the data matches up with what we expect. So how do we do that? What's like the quickest way to do that? We can do like inspect checkpoint Python. I think this is the easiest way. So import numpy as np. We can be like np load file. I think is what we found out last time we tried to do this, is the API we're looking for. I don't want this thing to be loaded from a pickle. This is where we got stuck last time. But there's like load from, there's like load numpy load raw data. There's like a from file. Here we go. So can we look at train output checkpoint 200 data bit bin, okay? Train output checkpoint 200 data bin. And I guess we want to look at this thing. We need to specify the data type here. So D type is float by default. Great. So floats is this. And can we look at, so if we like open the GUI here and we look at our, you know, layer 1 convolution parameter, like the bottom right of this kernel says 0.52638. This is not like the best one to look at, but we'll start here. So if we look at the checkpoint 200 spec, we know that this guy's at byte offset 0. So this isn't like super helpful, but this is like a good first pass. So if we look at floats 9, I believe we should see this. I believe. Okay. Python 3 inspect checkpoint. Oops. Okay. Not promising. Oh, unless this is upside down. Yeah, it's upside down. But it's still not right. Okay, can we, let's take a look again. Oh, that's, off by 1. My bad. So this is negative 6.6. Which none of these look like, which is concerning. Oh, but I guess this is not... We need to pause training when we checkpoint to do this comparison. Otherwise, it's not fair. So can we say that when we hit our first checkpoint, we just insta-pause? So pause is pause CL alloc checkpoint. Okay. So now we should train until our first output. And so now our weights should match exactly. Right? So here, now we should be chilling. Okay, so Python 3, inspect checkpoint. Yeah, this is wrong checkpoint. True. So this is checkpoint 100 now. And can we just print floats from 0 to 8 or something? Or 0 to 9? Let's just print like the first kernel that we're supposed to see. So do these numbers match up in any way? No. Maybe it's going backwards though. No, this is concerning. This is concerning. These do not match what I would expect them to look like. Because if I'm looking at the first convolution, parameter ID 0, I should be seeing negative 0.51 somewhere in here. Which is not looking good. So how did we fuck this up? Let's start by printing out, when we are writing this thing, what we wrote out. I think that's... saving this thing. And can we just say, like, we'll only print this for the first guy. If I is 0, then we print this. Just temporarily, I just want to see what the fuck is going on here. So does the data match what we tried to save, is the question we need to answer now. Whoa. What the fuck? Oh, oops. Wrong eye. I was logging the first parameter of every layer, not every parameter of the first layer. Let's try it again. Let's try that again. Okay, so he thinks he's saving this. Now, does that match anything that we see here? Maybe we were confused. Negative 0.51, 3.29, 0.52, 0.11. Okay, so this is right. So then why, when we say Python 3 inspect, does that not match? Maybe we have to write dtype is equal to npy float 32. Maybe he was using 64-bit floats. Fuck! It's okay. There we go. That's better. So this matches what we see here now, right? So I look at my weights here, negative 0.51, that's negative 0.51. If I go to the top right, it should be 0.040, which does match. Okay, cool. So now we have like some confirmation there. Now what we want to do is we want to start looking at like some of the deeper layers, right? So let's look at like layer 13 here. Can we look at the output of layer 13? So layer 13 is a 3x3 by 4x4. So we should be seeing that at the offset where layer 13 tries to say, can we just look at like the top left value actually? 0.04, it's upside down in OpenGL World. So 0.04123, that's what we're looking for. So if we look at our spec file here, training output, checkpoint, spec, and we look for layer 13, so 0, 0, can we do like something more intelligent? JQ, hold on, what is it? It's like JQ layer checkpoints 13. From train output checkpoint on Spectre.json. So we're looking at byte offset 1424. Let's see if that looks about right. So this is like lm offs is byte offs over 4. 0.41. 0.04123. 0.04123. So that's a really good sign. That's a really good sign. It looks to me like this is outputting somewhat correctly. Let's check the last guy. So this is plus 3x3x4. Something like this should be the last one. 21868. 21868. Yeah, okay. I mean 867 with rounds. So I think that this is right. I think that these weights are being exported correctly, which is pretty hype. Pretty hype. Okay. So now we need to kind of like add some way to load weights. So how would we do that? Okay, we have a few options. We could pass on the command line a checkpoint to load from. We could put in the config a checkpoint to load from. Or we could do both. To me, command line seems nicer for now. Because, like, what is the purpose of this thing? It's like we train something, we want to look at its output. Or, like, do some experiments. But, like, most of the time, it's not like we're starting from some checkpoint. Maybe in the future, if we want to do, like, pre-training on something, then maybe. But for now, I think it makes sense for us to just load a checkpoint from the command line. So let's do that. Okay. 8 versus 7 is rounding gap, is only in UI. We're going to face some loss and save load. No, it's only UI. It's only UI. I'm, like, almost positive. Almost positive. Like, because Zig is, like, limiting the displayed thing to 3 decimals or something, like 5 decimals or something. And so it just rounds if it's below. Or if it's too long. But, like, the raw float data is the same. Pretty sure. Okay, so let's say that we have, like, checkpoint here. And this thing is probably optional, right? Most of, like, usually we won't be loading a checkpoint, probably. And so here we're gonna have var checkpoint here is null, and if we see checkpoint as our argument, we say checkpoint is equal to it next, or else we log an error and print the help. Missing checkpoint argument here, and then here we do not have to actually validate that this thing exists because it's allowed to not exist. So we do this, and then in here we have optional arguments now, which is checkpoint. Initial waits to load. Okay, and I think we load the spec here. Like we have the JSON file is what we load here, I think. Yeah. Yep. Okay. So all we have to do here is pass that over to the training thread, probably. So where the fuck we do that? We just get like args checkpoint. So train thread now takes checkpoint, like initial checkpoint comes from, you know, a path. And so he needs to maybe load this thing. Okay. So I guess the question we want to ask ourselves is, who is responsible for loading this thing? I think ideally not the layer itself. I think the layer interface. The layer interface takes in, he knows his key and value. He knows his keys and like the dimensions that he's expecting. So I think I'm going to start at like the bottom and kind of work my way up. Started from the bottom, now we here. Shut up. Right, so if we go to like layer here, the options here are that when we initialize these guys, we initialize them with their checkpoints. Right? That's one option, is that like when we create this thing, we just have like conv layer has like checkpoint. Which seems very convenient actually. Versus like an API to load the checkpoint later. Yeah, I think that's very convenient. So here we pass in checkpoints, like layer checkpoints or something. So here now he has like layer checkpoints. I guess we want these as like wait param executor. And so then like the loading from the config file is like from somewhere else. And these are just passed in everywhere. And so the guys that need them get them. That seems great. Easy peasy. So now this guy's like, he needs to parse this thing. So I guess we have like, this is like initial checkpoint path. And we kind of say like, if initial checkpoint path, we have p, we must do something. We like open that file. Open file. And presumably we have like checkpoint load. Maybe this all lives in checkpoint. Yeah. This is kind of weird because it actually feels like the checkpoint, like the loaded checkpoint, is kind of different than the written checkpoint actually, right? Because like the written, like this waits thing, we want this to be like a std.fs file, I think, and then we can have like an API on this thing to like load, turn this thing into like a waits thing. You know what I mean? In which case we need to be a little bit more intelligent about this. So how do we fix this? I guess this file turns into a module instead of like a raw struct. And then everywhere, like when we had NN checkpoint here, this becomes lowercase. This is checkpoint. Oh god, this is gonna name. That's gonna name collide for sure. And then checkpoint, I guess we call this. Okay. So I think in NN checkpoint, this becomes like spec. And then this becomes, instead of stringify this, we're stringifying our spec. Great. And now we can have like loaded checkpoint. And he holds like layer checkpoints as a bunch of wait params, maybe already? He might. Yeah, he might immediately convert these into like GPU buffers. I don't see any reason for him to hold them as CPU buffers. Maybe he holds them as buffers here as well. That's like another option. I kind of like the idea of this type being like just ready to fucking go. Right? Because the write API takes in layers, and the layers export these. So there's no reason why this guy can't be like, give me some wait param executor, which means that he needs this to be a function that takes in the executor as a type for some reason. I guess. Okay. And then he has like, wait, that's kind of it. So this is just like load checkpoint, and he returns just this guy like straight up. Yeah. Yeah, something like this. Something like this. Invoke reversing. Thank you for the raid. What's up, guys? We are working on a neural network training framework. We are currently writing down what we have trained and trying to load that stuff back for a future training run. We've kind of been working on this like long-term project of scanning barcodes with a neural network. And of course, because we don't use dependencies, we have to write a whole framework from scratch. So that's kind of where we're at. I'm not going to get too much more into the details. Welcome. I hope you guys had fun over on Invoke Reversing stream, and hope you guys have fun here. Okay, so here, surely we have like some allocator that these things are going to live on when they get loaded. We have some executor that we're going to put these things on. And we have some sort of like spec path here. So we start by loading that spec, presumably. So we have like current working directory, open file of spec path, spec f, defer, close that shit. Okay, we probably want to read that into a spec immediately. So we have, you know, our spec is std JSON, you know, parse from token source, leaky sounds kind of right. Okay, so we probably have like scratch space that we need, which can come from like the back half of our heap bucket here. And we can do something like scratch, you know, checkpoint here. And later we restore that thing. Okay. This guy is like, yo, we're loading a spec. We are loading it on Scratch Allocator. And we need to come from scanner or reader. So we have like JSON reader and I don't give a fuck options, which means we need a JSON reader, which is std JSON reader from, again, we're using the Scratch Allocator here. And what else does he want? He wants the IO reader, which is the spec F reader. Okay, cool. So we should have a spec here. And I guess we do like, we allocate some amount of output here, which is like spec layer checkpoints len of wait param executor. Const executor is the type of this guy. Easy peasy. Easy peasy. So this is the like ret. Return the ret as you do. And so now we just have to initialize this thing. So for spec layer checkpoints and ret, we have like spec checkpoint, spec like layer, like def, layer waits def, I guess, or something. And like layer, like wait param out or something. I don't know. Wait param out has to be something. So he's probably like creating a tensor from this thing. So we have like executor create tensor. It's like something like this. And I think it's just like create tensor. So he takes in an allocator, initial data, and dims in. So the last thing is like the definition dims, easy. If this thing does not exist, so we have like, this is like the optional version of this thing. And this is like a opt, or else we continue and set wait param out to null. Okay, so that kind of covers that. Then this guy, he's like, we are going to put this stuff on this allocator. Hype, easy. And what was the other thing? The initial data, which is just, we need to like load the data. So this is like, we have some sort of like weights file. Data f comes from, we want to open something that's like relative to the spec path. So we want like dir name of spec path, easy. We like try, we like append that. We append something to this. It's like we have something like this as a path. And it's like the dir name of the spec path followed by the weights path that it's talking about, where it puts its binary data. So we have here the like bin path is this. So we open that thing, and we should just be able to be like data f seek 2, I assume, goes from the beginning of the file. Yep, so we seek to the beginning, which is, or we seek to wherever it says to go to. Layer wait def offset. Easy. Okay. And we just load that shit. So initial data, he probably comes from like scratch space probably. So we have like our scratch allocator allocate a bunch of floating point 32s that come from the dim size. So like total size based off layer weight def dims. Yup, and so we just need a quick little like total size function. And it's like for like var out is 1, while, you know, for each dims, we do out times equals d, and then we return out. Easy. Okay. Okay, so we get some initial data, and we put the initial data in here. I guess we have to load the data though, huh? Read all into initial data. Wait, this is all coming together quite easily. It all just kind of works. So there's like a non-zero chance that this is correct. And then when we call this thing, this is pub. So here, somewhere, before we create our network, we're like nn checkpoint load checkpoint for with cl alloc tracing executor and spec path. So this is just the p. Okay. So I guess here we have like checkpoint is maybe something like an optional list of optional and weights, wait param tracing executor. Yeah, this is what it is. Ew, what a fucking type. What the fuck type? If it's not there, then this is null. Hello, 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 hello! And then this thing must go in here. I guess this is, yeah, fuck it. So this thing, we just need to quickly throw a little couple of these on top. Cool. It's just fix me layer checkpoint type what the fuck. But now we should be able to be like, I think we do like this now. If layer checkpoints we look at LC at I, else null. So here's our checkpoint, layer checkpoint here, which lets us pass this here and here. Okay, and now all we need to do is like these guys need to support like all of our initializers just needs to take in a wait checkpoint if they have it. This seems temporary. Actually, spelling out checkpoint now. Sometimes. What's this about? No field. Okay, cannot format optional without a specifier. Where the fuck am I doing that? It must be here. Dir name. We'll just crash if it's wrong. Fuck it. Fuck it. No offset in this thing. True, huh? So this is the wrong type. This is kind of like this. In which case, for each layer, we need to be like layer out, I guess, huh? That's what it seems like. Why is this optional? Surely we just don't make this optional and everything's fucking easier, right? This just becomes empty list if there's no checkpoints? Yeah, that's way better. What the fuck are we doing? We're smoking crack, dude. Yeah, that simplifies a lot. Okay. Then like, why is there an optional here? Like, what the fuck are we smoking? Because our load checkpoint needs to return a list of wait params. That makes more sense. Maybe. Not sure. I think. Okay. So then here, we say like, this is how many layers we have. Then for each layer, we have like layer layer out. I guess it's like wait param out is equal to if layer wait depth, this is no longer optional. Len is equal to 0. We initialize this thing with an empty array. And continue. Okay, so that kind of solves that. Then otherwise we say wait param out is equal to an allocation of some form. And how many of these things are? Probably how many are in the definition. I guess. We're just following the types. Why are my YouTube videos demonetized? Yeah, titles like smoking crack for 2 hours straight. And then here, there must be some sort of loop over these things. And there has to be. I don't know what it is, but it sure seems like there should be. So this should be like layer weight def, param def, param out, or something. I don't know, man. And then like surely this goes here? That seems kind of right. Maybe. Param def offset doesn't exist. What is param def here? Layer weight def. So layer checkpoints is a bunch of buffers. So we iterate over the buffers. So this should be buffer. So then we should have byte offset, not offset. There we go. Byte offs here. There we go. Then all of these are param def, I guess. Slice as bytes here. And then we're kind of missing something here, I feel like. We're missing something here where we have the tensor here, but we also have to keep track of like his other shit. Right? Like the key has to come here, which comes from... I think we have to clone something here. The name, because I think we like loaded the config as a scratch space. It feels like the key lives here. I don't know, we're kind of just like going by whatever the types say we should do. But that feels kind of right. Hitting a joint every time Zig build doesn't work yet. Does this compile? Not quite. So this guy's like, I expected some shit and I found some other shit. So this is like this now, which means I guess this whole thing is optional though? Is kind of the way this is going? Okay, which means that this thing is now like double pointer, double slice there or something. And then here, does it all still kind of work out? I think so. Feels close. Expected double const... Oh, we forgot. There's an extra question mark in there. The type is a lot less stupid now. That makes like way more sense. Okay, conv layer, this guy needs to take a checkpoint here, right? So he's like, this is a optional list of wait param executor. And all he has to do is like, if this exists, he loads from there. Right? So he's like, if there's a checkpoint, if checkpoint, look at checkpoint 0 tensor. I guess we should be a little bit more clear than this. We should like assert if checkpoint I guess we'll just call it C here. If C key, if CLEN is not equal to 1, return error invalid checkpoint, right? If C0 key is not equal to kernel, then we also have a problem. If C0 tensor dims is not equal to my dims, if this is not equal to width, height, in C, out C, then like, fuck off. And if all of this stuff is good to go, then we say break block with C0 tensor. If all of this stuff is true, then we're kind of chill. Otherwise, we do whatever we were doing before. Seems kind of reasonable. Yeah. Okay, and then we have this guy. He's mad because expected this, found that. That's true. This should be constant, huh? Okay, so this guy needs to write U8 here. I got the fucking API wrong. This guy's mad because equal is a little bit tricky. Tensor dims. I think we just need to fix that. Okay, so other expects a tensor dims, but she should also accept an array of U32s. So I think it's like switch other type of other, and if it's tensor dims, he calls like equal inner self other, like this. Yeah. Else return equal inner self inner other. There we go. Easy. And then this is function equal inner, which takes in A and B. And then this stuff all just kind of works. There we go. So now that should work without any problems. Okay, fully connected layer. He also needs to take in a checkpoint here. So he takes in layer checkpoint as a what? Optional set of wait params given this R executor. Okay. So we say if layer checkpoint we do one thing. This thing is what? Waits is a executor tensor uninitial or undefined. And biases is also this. Then we can do this here, easy peasy. And then we do some validation on this thing, I guess. Hello, weights equals, biases equals, there we go. So if there is a checkpoint, what do we do? What do we do? What do we do? We check, we probably like figure out which key is which for C param or something. We switch on, I think these guys become like nullable. And this is like, we probably do like param key, something like this. We do like std meta enum string to enum on param key, or else return error invalid checkpoint. Easy. Switch on the param key. If we have weights, we go to weights is equal to C tensor. We probably need to do some validation here too, right? It's like if param, if like C tensor dims equal, and what are we expecting? It's like inputs and outputs. invalid checkpoint. Easy. You know, something like this. And here we do the same shit, right? So we're looking at biases here, and then the length, this is supposed to be 1 by outputs. All right. He says C tensor doesn't exist. Oh, param tensor, my bad. My bad. All right. This guy's mad because here we say weights, or else return error, missing weights, and missing biases. Maybe we just say invalid checkpoint on both of these. Okay, this guy's mad because layer checkpoints that we allocated here had a fucking question mark on him. So we just kind of like nuke that shit. Okay, this guy's mad because we changed tensor dims here. So we should actually just be able to replace this now with this actually, which is kind of hype. Kind of fixes a thing that we had, like this hack that we were doing all over the place before anyways. Nice fix. Nice fix. All right. All right. So we should be able to like make a checkpoint and load it now. Let's just go see what happens. Wrong folder. All right. So he does some shit. Okay, let's how do we make sure this like works? We train for a little bit, try to get some like okay results. Train a second time, load the checkpoint, check the results, see if they look like shit or not. I mean, even just actually calling this now train output 2 checkpoint from train output checkpoint spec. What we should see is if everything worked, if we look at the train output visualizer, zig out bin train output viz of train output 2, that's very promising. So our total loss starts at 42. Actually, that's pretty high. Can we compare this to train output 1? Yeah, okay. So what we see here, I mean, this isn't ideal. I would think that we should pick up like right where we left off, right? So on the, oh wait, no, this is backwards. Train output 2 is fucked. He starts just like absolutely fucking fucked. So this is backwards from what I would expect. I would expect us to start like kind of at the end of what we saw in train output 1. So something's wrong is the answer here. I don't know what yet, but something's wrong. It's weird though, because everything kind of ran. So I guess we just start debugging. Can we pause off rip? If we have a checkpoint, pause if we're paused, we can't initialize paused because the GUI expects a bunch of data to like exist that won't exist if we don't run one iteration. But we can do this. We can just hack this out. So you say, just don't optimize. if checkpoint, if initial checkpoint path is not equal to null, right? What's in trainer step? Yeah, this is like the optimization part. So if initial checkpoint path is null, then we are allowed to train. Otherwise, we just like don't fucking do jack shit. Okay. Which should allow us to inspect what we got. Zig build and okay. Okay, so we run this for a little bit. Move train output to train output back. Then we run this again. But we have checkpoint here from train output back checkpoint spec. And we can look at the weights here and see if they look kind of correct. So like we can just look at, hold on. We want to run this once before. Okay, so we have the original, our original boy, and then in a second directory, we run kind of the same thing. Outdir train output 2, checkpoint from train output checkpoint spec. Whoa, what is he pissed about? Background dir is not a valid argument. Okay. So we can start like comparing stuff in the GUI here. So we have original on the left. So surprisingly, these look correct. These numbers are matching up. What if we look at like, you know, our weights on the final layer? And can we like look at like, I don't know, this guy? Weights, final layer. Okay, so this looks obviously wrong. So it looks like maybe either our fully connected layer loading is broken or fully connected layer saving is broken. Can we look at maybe, okay, this conv 1 by 1 by 4 by 4, layer 20. Does that still look okay? No, this also looks broken. So it looks like the first layer loaded correctly, but the rest didn't. Can we look at like layer 3? Yeah, everything's broken. Okay, so the first layer loaded and everything else didn't. What the fuck? So we checked at some point that the output was correct, so I think that that's probably okay. Let's look at the loading logic. So here we iterate over this guy. Here we allocate some weight param out, great, and then we iterate over weight param out. We create param out. That seems all kind of reasonable. Oh, yeah. I mean, our data. This stuff will like go out of scope before this finishes loading. This create tensor untracked needs to be like tensor load results is executor create tensor initial data param def dims, and then here we need to do like tensor load res event wait here to wait for this to finish, and then assign. That's what it is, probably. That's my guess. We forgot to try somewhere. Whoa. 458? Oh, this, that's funny. We just haven't called this for a while. So this has just been broken, but that's fine. It's offset 0. And tensor res is probably val or something. Probably is the correct thing. Cool. So can we look at train output 2, delete that shit, and run? Okay, so that looks more promising. Weights here, let's kind of go all the way to the end here, and just kind of see if we think that this looks the same, right? So here we go all the way to the end, kind of come over to the right side, and I think this is right? So this is 0.371, this is 0.371, this is 0.054, 0054, negative 046, negative 046. Great, let's check out one of the conv layers back here, layer 18 maybe. Reset, reset. Yeah, those are the same. Negative 3980. Yeah, I think that's right. I think that's right. Or you can also tell because loading from this checkpoint, we're not optimizing at all, right? But he does have like semi-okay boxes. So what we should be able to do now is undo some of these fucking hacks. And just do some like further testing. Further testing. Okay. So let's not do this hack. And then let's not pause every time we write a checkpoint. Let's reduce our checkpoint frequency a little bit here. You know, it's kind of high. So can we do like every maybe 1,000, 5,000 iterations maybe? And let's try to train one version of this guy that works okay. Let him run for a little bit and then try to load him again and see if he's still, like, if he immediately is okay. You know what I mean? You know what I mean? That would help us, like, gain confidence that it's relatively correct. Okay. So let's run this thing. Background, dir backgrounds. Config comes from default config. Out dir is, you know, initial run or something. We'll let them run until we think the boxes look not like so much like shit. And we get like a checkpoint here. So initial run, no checkpoints yet because it's only every 5,000 iterators. How many iterations have we done? Right? Like was this a bad? We are in iteration 1,000. Okay, so I think that by the time we get to iteration 5,000, we should already be on something like relatively okay. So we'll just kind of wait for that thing to show up. Let's check again. We're at iteration 2,000. So we have to wait, I guess, another minute or so. Sorry. Maybe we should have been a little bit less ambitious. 2,500. But on the bright side, look at those boxes. Look at those banger boxes. Those are pretty good. Pretty good. Shouldn't loading box checkpoints instead include the step count so that when you restore it continues from 100 or wherever, that way we can save new checkpoints in the same directory? Yeah, that's one way. For now, I think that we're kind of viewing checkpoints as like not a thing. We're not really like thinking about resuming training right now. We're thinking about starting training from the context of an existing checkpoint, which is like slightly different. It just means that like we don't support like continuing the same directory, which is like fine for most, like that's a fine V0, right? Because I think that doing more is like more complicated. Still not yet, huh? 4,700. It should show up soon. Should show up soon. There we go. So there's our checkpoint. So we close this thing now. And we want to run 2. Wow, last stream I watched, the boxes weren't really nearly as good. Well, to be fair, This happened at like midnight last night. I ran a bunch of experiments off stream. Basically, I should have mentioned this earlier. Healing the orientations of the predictions to match of our labels to match the predictions really helped. Right, the orientations needed to oh, actually, no, this is not midnight last night. This is noon today. Sorry, this was noon today. So like if we predict left, but the barcode was oriented right, we just flip the label so that the loss gets lower. I also made it so that the barcodes were bigger and more visible because there were like a lot of scenarios where they looked kind of hard to visually like when I was looking at it with my eyes, I was like, that's hard. So I just kind of made them bigger and fix the rotation prediction. Okay, so we should be able to run 2 now. So if we look at this guy, we have backgrounds. We have config, the same default config. Really, I guess it makes more sense to load it from initial run config JSON, and then checkpoint should come from initial run checkpoint 5000 spec, and then our outdir is run with loaded checkpoint. And we should see that these look great, like off rip. Oh yeah, that's so good. I mean, great is strong, but I mean, they start correct. And then if we compare these runs, so we look at like initial run log CSV and run with loaded checkpoint log CSV, yeah, we see that like the green line starts like basically where the blue line ended, which is hype. That is sick. Okay, so I consider that a win. It's a good place to stop for today. Thanks for watching, guys. If you like what you saw, we stream most days. We aim for 12:30 Pacific time to 4 o'clock Pacific time. It is almost 4 now. So if you want to catch us live and you're watching live, anywhere between 3.5 hours ago-ish and 15 minutes from now is where you should expect to see us live. If you can't watch live but you want to keep up, there's a YouTube link in the Twitch description where feature development typically goes up. So this checkpointing thing would definitely go there. Sometimes if we're doing something that's more like cleanup or reading, research, that type of thing, that might end up in Patreon or YouTube members or Twitch VODs exclusively behind paywalls. We do that because, the stream will stop happening when I run out of money. And so I want to be able to give something back to the people who want to support the stream's longevity. And so we give them the rest of the VODs. But you shouldn't really miss anything too important if you just watch the stuff that goes up on YouTube, so no pressure, obviously. Yeah, I think that's it. Thanks for watching, guys. I think I should see you tomorrow. I guess I have to think about what we would do tomorrow. I might have to run some experiments, so it depends on where we end. If I come up with a stream idea for tomorrow, but if not, definitely the day after. So yeah, thanks for watching. YouTube, peace out, and Twitch, let's find someone to raid.